as many of us have learned, or I hope everybody learned, the greenhouse media is fairly sterile, right? So there's not a lot of nutrients in there, if any at all, depending on what you've got. So what we did the other day with our little experiment is a pre-plant fertilizer. So with the, and that's why when we took a look, it was interesting too to see that there wasn't a lot of difference between the fertilizers. Now, again, an organic fertilizer is going to be more of a slow release. The liquid fish is going to be a little bit of, it is absolutely a faster uptake for plants. So you might want to do a combination of both. Foliar feeds, what does that mean? That's when you've got a water-soluble nutrient, you put it in a backpack sprayer, and you literally spray your plants, okay? I've done that. I like doing that. I think that that's a viable option. Certain nutrients or certain fertilizers and mixtures can very often have a whole array of benefits to that foliar feed. We'll talk more about that, a little bit more about that, I think. It's not real common in greenhouse management, although there are certain foliar feeds that will, cause a plant to snap out of a deficiency quite quickly. So we'll talk a little bit more about that next week. Osmocote is a very popular and well-known pre-plant fertilizer. This could also be a post-plant fertilizer. So post-plant, what does that mean? Obviously, very different from pre-plant, right? It's after the plant's already been potted in the pot. So this fertigation is all post-plant. The fertigation that we talked about. Osmocote can also be a post-plant. It could be something where you add a little top dressing to the plants once they get potted up, after they get potted up. My preference with the Osmocote is to put it a little bit below surface level. If you buy nursery plants, you often see that pelletized Osmocote or some version of it. There's another one called Nutricote. They have slow release, they have heat release, or temperature release, I should say. I like the slow release versus the temperature release. Temperature release, if you get a hot couple of days, you might get a flush of fertilizer and a flush of growth that you didn't necessarily want. So the slow release or the time release capsules are the best. Let's see, what else do I want to say about that? I think that's it, but at any rate, there's other versions of Osmocote. That's just the one that we see at the Home Depot, right? So that can be a pre-plant or a post-plant. It's usually a post-plant though, like I said, and even in the sense that you just transplanted the plant, you might add the Osmocote to it. I would still consider that a post-plant. It's not mixed into the media itself. There's a level, a depth, I should say, that you want to get that fertilizer, so it's not thoroughly mixed in, whereas we thoroughly mixed in the this Happy Frog Jumpstart into our mix. So that would definitely qualify as a pre-plant. What else do I want to say about that? I guess that's it for now. Okay, systems for monitoring nutrient status. Okay, so how do we monitor the nutrient status of our plants themselves? Okay, so there's 4 different ways for monitoring nutrient status. So one way we might do that is if we're using the fertilization through the water, fertigation, we might do a water analysis. We might do what we will learn, if you haven't learned this already in your world, is a visual diagnosis. Okay. The other thing that we might do, I hope you're not surprised, is that we might test our soil. Okay. the last is to take what we call there's a couple of different ways you can refer to this, but it's a foliar analysis. Another referral or way to label it is called SAP analysis. And you've heard me talk about John Kemp. He and his team often recommend a SAP analysis or this foliar analysis. And the reason for it is if you really want to know what's going on in the plant, in the moment, in that time, this is going to tell you what's going on there. You know, a soil test is going to tell you what's going on in the soil. Is that what the plant is taking up exactly? No, not necessarily, right? But it can lead you down the road to say, oh, okay, well, my pH is off. I got plenty of nutrients here, but my pH is off, so that's why I'm seeing a deficiency in X, Y, Z. A visual diagnosis. What's the gigantic, massive drawback there? What is the massive drawback there? Visual diagnosis. It's usually too late. So, and that's something we will learn. Obviously, we need to learn that. But it usually happens that we see these deficiencies after they've occurred, right? You can't see them before they're occurring. So in a lot of cases, at that point, it's partially irreversible. In some cases, it could be completely irreversible. I think many of us that grow plants have seen a nitrogen deficiency, let's say, and we've been able to pull it out of that nitrogen deficiency just by potting it up into a new pot or adding fertilizer. That tends to be one that's a little easier to pull plants out of. However, there are other deficiencies not so much of an easy time. And the other part of it is that what we're learning is as our plants are lacking nutrients, we are absolutely seeing the occurrence of disease in insects much quicker and much more prolific because that plant has a weakened immunity. The insects are able to pick up on that. So nutrient deficiencies can have several different symptoms, and some are very specific to a particular crop. So this goes back to that thought of learning your crop so that you know what symptoms to look for or what nutrient deficiency to look for. Some are more typical than others. Okay? So when we talk about these issues with our plants, you know, in some cases it's very difficult to know. Is it a nutrient deficiency? Is it a toxicity? Is it an insect? Is it a disease? Is it environmental? Is there an environmental stressor? Did the plant get too hot? Did the plant get subjected to too much sun? Was it too cold? Did it get subjected to frost? So there's a lot of different potential players in what is wrong with my plant. I always wanted to have like a little booth out at somewhere like at the fair or something and call it like, what's wrong with my plant? And then, you know, like Lucy, Charlie Brown has like 5 cents, so people pay me like 5 cents to tell them what's wrong with their plant. Doesn't mean I'm going to tell them exactly what's wrong with your plant, because honestly, the best way to know is through a SAP analysis. And I'm not sending everybody's stuff away for SAP analysis, obviously, although we could make a business out of that, right? Which is what John Kemp's done to some degree. He's also selling nutrients, so there's that. And I might look for a podcast of his. I don't know that he does anything with greenhouse management though. But what I'll do is, because I do believe we will be remote next week, what I'd like to do is look at at least 1 or 2 podcasts for you guys to watch, and then we could maybe do a worksheet in combination with that. But just to finish up today, because obviously, even though I had good intentions, it's hot in the greenhouse, so I need to turn the fans back on, as you all can imagine. So let's just finish up. So how do we talk to each other about these deficiencies, these issues that we have with plants? Well, we have a few, definitions that we typically want you to learn, or we. Who's we? I don't know who we is. Me and all the other people who like to gab and grow, I guess. But at any rate, that equals teaching horticulture, aka teaching horticulture. No, well, kind of. But at any rate, there's a few terms that we use in our industry so that we can talk to each other about these problems, okay? And I'll try to find examples because I bet you we have them all over here, okay? So the first one is chlorosis. What does chlorosis mean? Chlorosis literally means that the green chlorophyll of the plant is lost. So lacking green chlorophyll, lacking green pigment. That is chlorosis. So lack of green pigment. So does that mean the plant's always yellow? No, it could be white, right? That's lacking green pigment. We have some really good examples. These, I think they're cucumbers maybe, are chlorotic. You could just say they're overall chlorotic. They are experiencing overall chlorosis. When you go to, next week we're going to get deeper into, and this will be part of your reading as well, but we'll get deeper into what leaf is it occurring on. Is it an old leaf or a new leaf? The chlorosis, and in this case we would say chlorosis is occurring on old leaves. The new leaves still look relatively green. And so why is that important? Because certain nutrients are mobile within the plant. So certain nutrients move from the old leaf into the new leaf. So that green pigment, in the sense that we're talking about chlorosis here, is moving from the old leaf into the new leaf, and the new leaf is remaining green, whereas the old leaves are chlorotic. All right. So the opposite, that is referring to a mobile nutrient, the ability to move. And then the other is immobile nutrients. Immobile nutrients stay in the old plant, stay in the old leaf, stay in the old parts of the plant, so therefore the new growth is lacking green pigment if we're talking about chlorosis. Knowing these different pieces, whether the nutrient is mobile and identifying that the chlorosis is in the old leaf, gets you closer to what nutrient deficiency are we looking at, okay? And in some cases you might be looking at several. I mean, these these plants are suffering quite a bit because another thing that's happening, and we'll see this in our little basil demonstration, or part of the class, because we talk about basil, because basil tends to show nutrient deficiencies very well. It's a good little textbook. But the other part of it is you can see that they're already going to flower, or they're attempting to go to flower. Why is that? This is an annual. When annuals are suffering, when they are lacking their nutrients, their objective is now to set seed and procreate before they die. Like they sense that they're about to die because they've lost nutrition, or they are lacking nutrition. So in an effort to do their job on this earth, they want to procreate. Another good example of, general chlorosis is the geranium leaf, the old geranium leaves, the older geranium leaves look overall chlorotic. All right. And I just have that the leaf turns progressively lighter green and finally turns yellow. That's chlorosis. Overall chlorosis, okay? The other common is necrosis. And that is referring to death of plant cells. So this usually manifests itself in shades of brown. Okay. Again, we can look at the geranium plant, and you could say the oldest leaves are completely necrotic, curled up even, And the next to the oldest, the slightly newer leaves are chlorotic. And we are even seeing, well, I'll get to that. But this is a good example of necrosis. Now, necrosis can look a lot of different ways. You could have a necrotic leaf margin. So that's an entire leaf that is necrotic, right? You could have, we've learned with the lettuce, this calcium deficiency manifests itself with necrotic tips on new growth. So this would be potentially necrotic leaf margin, you could say, about certain plants or certain deficiencies, okay? Or there could be cells within the leaf, veins that are necrotic, okay? So, and that's what I was starting to talk about with this geranium, is the veins, right? So, as with our plants, all of our plants, they have veins in their leaves, right? So if we're seeing, in this case, it kind of looks like, I mean, this looks a little bit more like an overall necrosis, but we might see what we call interveinal chlorosis. What does that mean? Well, it means that it's chlorotic between the veins. It's chlorotic between the vascular tissue. And you know, those rhododendrons really show that very clearly when they are showing an iron deficiency. Magnesium shows up as an interveinal chlorosis. So those are, again, clues to let you know what you're dealing with. Is loss of pigment, green pigment between veins remain green. That's going to get you to the answer there. And then the other two I want to show you some pictures of. We don't actually have these in our greenhouse right now. One of them is called a witch's broom. And the other is called strap leaves. And I do have some pictures of these in a PowerPoint, so I'll share that with you on Monday. And basically the witch's broom is when you've got like a very strange group of growth. It happens, gosh, I'm trying to think of a plant that it typically happens to. I've seen it happen on kale, and the other one I've seen it happen on was broccoli rabe, so same family. And what that meant in the broccoli rabe was that we were looking at a boron deficiency. Now, boron's a micronutrient. It's needed in a very small amount. However, without boron, you will see deficiencies. So it's an interesting thing because most people really neglect to recognize the fact that these micronutrients play such a big role. That's why they're called essential nutrients. So if I asked you on the quiz, what's the most important nutrient? What is the most important plant nutrient? How would you answer that question? How would you answer that question? That's a trick question, right? They're all important nutrients. If you give me an answer of one particular nutrient, I would say, nope, wrong, sorry. You could argue with me, because I think that there is a debate there. So don't argue with me, I guess, debate with me on it, perhaps. But in my opinion, they're all essential. Without one of them, you might not notice the deficiency. However, you probably would notice it if it were nitrogen, because nitrogen is needed in the largest amount. It has the largest relative abundance in a plant's dry matter when you dry it out, right? So that's an easy one to debate. However, if you're missing boron, you're going to see a deficiency, right? If you're missing molybdenum. So this is a good example of chlorotic leaf margins, and this is a good example of necrotic leaf margins. What's happening here? I don't know exactly, but I'm gonna guess. I mean, this comes from the cucumber or the cucurbit over here that got potted up. I'm gonna guess that they were in their containers for too long. This is one of those moments where I'm not sure you're gonna bring this guy back, you know? This plant is showing a couple of different nutrient deficiencies perhaps, or the progression of one nutrient deficiency. Again, this necrotic leaf margin is happening on an older leaf, so perhaps this is going to end up being necrotic in the end as well, the leaf margin, whereas the new growth is still relatively green. However, you can see that this plant is set in seed or trying to set flower, and at that point it's an annual. Annuals, they want to live fast and die young, so this one's out to procreate. A way you could potentially keep your plant in a more juvenile state is to clip the buds off, the fruit buds off, and it could create it, it could cause it to stay juvenile, but at this point, I think this one might be a little too far along. Another deficiency that we talked about in the class was phosphorus, right? Phosphorus deficiencies. Phosphorus deficiency shows itself very quickly in everybody in that Brassica family. We tend to see it in, usually we see it in here with the arugula, because the plant propagation, I think, does like a little arugula experiment. I don't think they did that this year, but at any rate, it shows itself very quickly, and that phosphorus deficiency is in that macronutrient place, so it is possible to bring it out of it, but you got to catch it before it gets too far along. So best way to know exactly what's happening in your plant, what kind of test would you do? Foliar or sap analysis. And like I said, we'll talk more about that, because well, I don't know how much more we're going to talk about everything, but I keep thinking we're going to have more time to talk about everything, so hopefully we will. At any rate, I'm going to finish up there. What I want to have you guys do is to read the paper that I assigned, and I'd like to assign a worksheet to go with that, so that will be part of your grade. We also have those questions from the compost, so we will cover that. I'll put that in an actual assignment as well. So there you have it for today.